Hey, this is Garrett. Take a look at this hydrocarbon list with me. Listed on here are hydrocarbons by number of carbon atoms in each compound. So the first compound we have on our list is methane, right? That's our natural gas. And it's got one carbon atom. So it belongs at the top of our list. If you look at that structure diagram, we see the one carbon atom with the 4 hydrogen atoms around it. That's the structure that all of these hydrocarbons are going to have. But if we increase the number of carbons, we have to increase the number of hydrogens as well to keep that ring of hydrogen around them. So if you look at methane and nonane, you'll see the difference between 1 carbon atom and 9 carbon atoms. We've got a short chain methane, short chain meaning just 1 carbon, and we've got a medium chain with nonane meaning 9 carbons. So yes, the number of hydrogen will also increase, but we're not going to do any counting by nitrogen, only by carbon. And we're going to think about the heat content primarily coming from the carbon during combustion. However, we do still get a little bit of heat from hydrogen when it changes from the hydrogen in the form it's in now to H2O. When it changes into water vapor as part of that byproduct of combustion, light, heat, potentially poison gases, as well as a little bit of mist, a little bit of vapor. That H2O comes from, well, there's the H, it's already supplied with the hydrocarbons. Oh, and the O comes floating in the air with that requirement met of bringing oxygen to the fire. So, yes, the hydrogen are important, but that's not why we put the list together. This list is by carbon atom number. So this list goes from 1 to 12 and then jumps to 17. Why I decided to jump all the way to 17 was because at 17 carbon atoms, we now have what we can refer to as a long chain hydrocarbon. So these are all hydrocarbons, but at 17 carbon atoms, that's a long chain. Long chain hydrocarbons are all solids at room temperature, meaning this is a wax, a paraffin wax. So I don't know all of those compounds after. I didn't know all of the compounds before. That's why I stopped my list at 12. But at 17, they become long chain. Everything under 17, from 17 to 5, are called our medium chain hydrocarbons. Guess what? Those are all liquids. And so if we have our solids at long chain, liquids at medium, then our short chain hydrocarbons are going to be gases. And there's not too many of them. And as a matter of fact, it's just the first 4. So a chain can be 1. That's why methane is included as a short chain. Methane, ethane, propane, and butane, our first 4, are considered short chain hydrocarbons. The characteristic of short chain hydrocarbons is that they're gases at room temp. This helps to make methane an ideal fuel for us, due to the fact that the characteristic of short chain hydrocarbons is volatility and flammability. Definition of volatile means how easily will it convert to a gas, to a vapor. So we know that greasy, oily rags in a trash can could be a fire hazard in the shop, in the lab, in the classroom, because of the gas that those oily rags give off. That's a slight volatility. They're not gassing off at a tremendous high rate. Well, the methane is already a gas, so its volatility is pretty high as a gas to stay a gas. So that volatility is what we're looking to use to ignite that flammability, right? We're going to ignite the gas off of something rather than igniting the internal solid core of something. It doesn't work like that. So, quick recognition of hydrocarbons. Methane, with its low carbon count, does not have as high of a heat content as some of the other ones with higher carbon and hydrogen contents, but we knew that. We knew burning natural gas isn't like burning a solid. It's still a gas, but it's the volatility, the ease at which we can ignite it, which makes it our good fuel.